Hey everyone, welcome back to Girl Coder. Today we're gonna learn about programming logic and algorithms using Python. So in this tutorial we're gonna go through the theory stuff followed by some interesting exercises and examples implementing this theory. So in this session we will cover algorithm, some algorithm representation methods followed by pseudocode and that followed by some interesting flowcharts and some cool examples using Python. So guys, what is an algorithm according to you? What you'll be thinking if you have this algorithm into your mind, like if this thing pops into your brain, you'll be thinking that it is a step-by-step thing that we have to do in order to solve something, right? Yeah, that's it. You are really right. That's pretty straightforward, right? Algorithm is nothing but it is a step-by-step procedure that we follow in order to do something or in order to solve a problem. It is also a sequential solution to any problem written in natural language. For example, if you want to go to shopping, first you have to list the items that you don't have. So that's step 1. And the second thing is in order to do shopping, in order to get those items, you have to go to the shop. So that's step 2. Step 3, you're going to grab all this list of items that you have in your list and you're going to complete the shopping, right? You're just following a step-by-step procedure while doing shopping. Or when you're watching a video, what you'll do in a YouTube. For example, if you want to watch a coding video, you're gonna go to a search bar, you're gonna write that video that you want to watch, you're gonna search, you're gonna do that, and after doing that, you're gonna tap the video that you have and you're gonna watch it. It's like a step-by-step thing. Whatever you're doing, you're not doing all the steps at the same time, right? You'll do from the step to step. Even when cooking, this is the best example for algorithm. Even when cooking, you will follow step by step in order to complete the dish that you desire to eat, right? Okay, so why do we need algorithm? What is the purpose of using this algorithm? So the main use of algorithm is to help us translate English into the programming language. Okay, let me give you a metaphor. For example, there is a person who wrote some code, for example, addition of two numbers, which is really basic stuff where you can understand it easily in an easy way, okay? So when you're seeing a code that is written by someone, will you understand that code? Just imagine. Oh, it's like a Greek and Latin for you, right? It's completely an uphill battle in order to understand that piece of code that is written by someone without any comments and without any description, right? So, in order to solve that problem, we need something that can understand, that can help us to understand that code. So for that, we use algorithm. Algorithm is nothing but if that piece of code is written by someone, and if that person will write some step-by-step things in order to describe that code. So if you read that algorithm, you'll understand like what is doing what in that code. Okay, like algorithm is nothing but it will just describe the piece of code that you have and it will explain you each and every step, so even a normal person can understand that code, that piece of code, though he don't have any coding knowledge. He can just read that step by step algorithm and he can understand. That's it. So for that we use algorithms in computers. Okay, here we have some cool features of algorithm. Let's see. Any and all instructions must be precise and unambiguous. It means each and every instruction must be precise and clear. If you are describing a code, you don't have to write the entire description. Like in pairs and pairs, you just have to write a single line which can explain everything. Okay? And each instruction's execution time must be terminated. If you're writing an instruction in an algorithm, then that must have some starting point and some ending point. Okay? Like for example, if you're adding two numbers, you'll take a b as input and you'll just add it and you'll just show the output, right? That has some, it's like it's working for a specific period of time and it will just terminate. So in that way we have to write an algorithm that must in such a way that it have to terminate, it have to come out of the loop. It must not be in loop all the time. Like for example, for a loop, if you give a loop with a false condition, like if you give a loop which is infinite, then it will be running and running and running, and in the end, that will become something that is horror, that you can't even imagine if that thing happens. So we have to write an algorithm, a step which must have some starting point and some ending point. Okay. And also, in order to terminate an algorithm, you need a condition, and that must be like this: a condition that will terminate. Okay. So there must be a termination condition. And one more thing is, this is really important: an algorithm can accept no input, and it also accepts more inputs. Like, it accepts zero input, and also it takes more input, but it must produce output. Output is really important. Like, each and every person will write algorithm or program for some output. So output is mandatory. Input, though you don't give any input, it will run some way by some other conditions, and then yeah, it will produce output. So we need output. We don't need input. Sometimes we need inputs. It depends upon the problem that we have. And one more thing, it can accept any type of input and produce a corresponding output. Okay. So it depends upon the problem, as I said before. Now let us see the general way to write an algorithm. Like, what are the steps that we have to follow an algorithm? Like, we also have an algorithm to write an algorithm. Sorry, I'm just kidding. But yeah, we have some steps that we have to follow in order to write an algorithm. So the name of the algorithm must be specified. Okay, you have to give some name to the algorithm. And algorithm must have some starting point, and algorithm must have some ending point. As I said before, it must have some starting and it must have some ending. Input and output descriptions can be included. You have to include input and output descriptions. Okay. Input you can give or you cannot give, but output, it is mandatory to get the output, to get the desired output from the algorithm that you have written. And the step number must be included for identification, like step 1, step 2, step 3. You can write like that, or you can just use 1 to 3. You can also use step 1, step 2. It will be easy for you to understand like each and every step. So each step can have explanatory note enclosed in square brackets followed by an operation. It's like, if you want any extra points for explaining that particular step, you can include them by using some square brackets. You'll see that in the coming moments. And algorithm completion must be specified as final or stopped. As I said, it must have some starting point and it also must have some ending point. That's it. So these are the steps that you have to follow in order to write an algorithm. You'll just understand while writing an algorithm, so don't worry. So in order to represent an algorithm, we have two ways. One is flowchart, which is graphical representation, where you'll use some sort of symbols to represent that algorithm. That each and every step you'll represent using some specific like symbols. You'll know that in the next coming thing. It is mainly used to help the programmers to understand the programming logic. Like, it will be, if you have this representation, graphical representation of algorithm, then it will be easy for programmers and for us as well in order to understand each and every step that we are doing in a program. That's it. Pseudocode is nothing but, instead of representing graphically, we'll use step by step: step 1, step 2, step 3, using textual writing. Yeah, like using texts and all. That's it. It's a kind of like that. Now let's see the best examples of pseudocode, the best and basic examples for pseudocode. For example, here we have adding two numbers. So what do you do in order to add two numbers? The first and foremost thing is, you'll get the numbers, right? You'll get those numbers A and B. And next, you have the variables A and B, and now you have to add them, right? So for that, you use addition. So the step 2 will be calculate addition. That means extra things. You're writing extra things, explaining extra things in square brackets. Understand? See, here taking inputs A and B, doing sum equal to A plus B. These are extra things for explanation. So we are keeping them in square brackets. So what are we doing here? Calculate addition. We are just adding A and B, and we're just storing that in a variable called sum. Print the results. How we are going to print? Using sum. That's it. So we'll just get the numbers. That is step 1. We'll calculate addition. Step 2. We'll print the results. That is step 3. You can write, you can also write step 1, step 2, step 3 like this as well, or you can use 1 to 3. it's your wish because you're the one who is writing algorithm, but it must be in like unambiguous. It must be clear, like other person, if the other person and coming and reading your problem or your code and reading this algorithm, it must make sense to them, like they have to understand this. Okay, now for example, we have area of circle. What do we need? The first and foremost thing in order to find the area of circle is we need radius. That's an obvious thing. So we'll get the radius. That is step one. And later we need the formula in order to calculate area of circle, and that is pi r square. And this is pi value. And we'll compute that area. And that is step two. And what are we going to do? We are just going to print that area. That is step three. In this way, we're going to write pseudocode. And here we have some cool notations that are used in the flowchart. And this is an arrow. This is nothing but it represents the sequence of steps and also the relations between the blocks that we have. Okay. And this is an input and output symbol where you will give input and output in this particular box while describing an algorithm. And this is a decision symbol. Here is where you write conditions. If yes, it will go somewhere. If no, it will go somewhere. And there will be some block of code and you'll just represent that. And here you have start and end symbol. You'll use this block for starting and ending. Okay. And here, this is nothing but the step that you are processing. A processing step, an action that you're taking. If yes, what? If no, what? If yes, you are doing something and that will be done in this block. If no, that also will be done in this block. Okay. And here we have a connector symbol that connects. And here we have a subroutine symbol. We usually don't use these two symbols much in the algorithms. But yeah, we do have these kind of things. Now we'll just solve some algorithms using Python. Okay, get ready. So here we have an algorithm for adding two numbers. What you'll do, you'll just start, you'll accept number A, you'll accept number B, and you'll just add, and you'll just display the sum value, and you'll just stop. Starting and stopping. Okay, and if you see the flowchart, see this is the starting point and this is the ending point. See the symbols. Here you see receive A, you are taking input A, you are taking input B, and you're just doing sum equal to A plus B, and you're just showing sum, and that's it. Okay, let us do this practically by using a coding editor. And here I'm gonna use Python. Okay, my favorite coding editor is VS Code. So I'm gonna open VS Code. So here, let's start. Okay, starting receiving A, right? Here in Python, we'll receive A by using an input method. So I'm creating an A and I'm taking input method. Okay, if you want, you can also convert this to integer by using int method. That's it. You took A. Now let me take B as input, and this also will be an integer. So I'm gonna take B this time. This will be B, right? And yeah, we have A and we have B, and now we're gonna do sum. So I'm gonna create a variable sum equal to, we're just gonna add A and B. That's it. So this step is also done. Now we have to show sum. So for that, I'm using print. Obviously in Python, we use print method in order to show the sum, something, whatever you have, you're just gonna use print. And that's it. The algorithm is done. See, by using this flowchart, it's really easy for us to write code. So algorithm, like if a programmer writes an algorithm, for him, it will also be easy. Like if we have some complicated things that we have to deal with, then at the time we can use algorithm. Pretty simple, pretty straight. Yeah, pretty simple. Now let me run this. I'm gonna give 1, 2, 3. That's it. The output is 3. Pretty simple. Now let's go to next algorithm, and this is write an algorithm to print the largest between two numbers. Okay, Let me write an algorithm. In the same way, we're gonna take A and B as input, and these two will be integers. And after that, see, this symbol is conditional symbol. If true, it will do something. If false, it will do something. Okay? So it will true, false. Okay, if true, displays A, and if false, it displays B, and it will stop. And that's it. So A and B is done if A is greater than B. So I'm gonna create an if block if A greater than B. If that's true, obviously it will print A. I'm sorry, A. What the, okay, A. Else, print B. Friend, we're gonna print B. Done. That's it. And yeah, you're just going to stop, and let me save this and run this for you guys and see. A value, for example, is 2. B value is, for example, 6. In this case, 6 must be the output, right? Because we need a bigger number. See, the output is 6. Wow, that's cool. Implementing algorithms is pretty simple. Now let's go to the next one. And this is the largest of three numbers, and I want to give you an assignment, guys. Okay, do this not for me, do this for you. I'm going to give you this as an assignment. You're going to print three numbers, like follow this algorithm step by step. First, you're going to start, you're going to take A, B, C as input. You're going to see whether A is greater than B or not. If yes, go. If no, go. Do this. And yeah, in the same way, complete this algorithm and write a piece of code and send me that piece of code. Let me see like what you guys are up to. Okay, okay, let me do this one thing for you guys. Okay, okay, first we're gonna take count. Let me clear this one. Count equal to 1. Done. And display count. First we're gonna display count. Okay, so print initial count is something. Initial count is 1 actually, so count. Let it be like that for a while. Okay, initial count is count, and then we are displaying count initially, and we're gonna count plus 1. But for that, is count less than or equal to 10? Okay, right. So if count less than or equal to 1, we're gonna increment count by 1, right? It's not less than or equal to 1, I'm sorry, it's less than or equal to 10. Yeah, it's less than or equal to 10. We're gonna do this, right? That's it. And let me print count for you guys so that you can see. Am I doing something wrong? Right, I'm doing something wrong. Here, it is a loop, right? When we have a loop, we have to use a looping statement. So this arrow represents a looping thing. It means it will loop. Is count less than or equal to 10, it will go and it will again display count and it will print. See, in this, like see here, we are doing a mistake. Like people mostly do these kinds of mistakes while following the algorithm. We'll just see the arrows that we have, and we're gonna skip these kind of looping arrows. So be careful while following the algorithm. Even consider these kind of things as well. Okay, so here start, we are done. Count equal to 1, that is initial count. And now we're gonna display count. Initial count is 1. Okay, just for our convenience we are doing that. And now here we need a count like that must be a looping count, right? So for here I'm doing while loop. Okay, while count less than or equal to 10, we're gonna count and we're gonna print that count. That's it. Let's see whether it will run or not. Here we are not at all giving a single input, but we have to get an output. Let's see. Let's save this and run this. Oh yeah, initial count is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Why are we getting 11 here? So this must be less than 10. Let me rerun this one. See, yeah, initial count is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, initially we gave here 1, and yeah, it must be less than 10. Yeah, it must be less than 10. So yeah, in this way we'll get. And yeah, let me do this. I think this is the last interesting exercise that we have. We have to print the area of circle. Okay, what do we need in order to get the area of circle? We need radius, right? So first and foremost thing is we're gonna take radius from the user as input. So radius equal to end of input, right? Done. And now we are going to give pi value. It's 3.141. It's 22 by 7, right, in math? 141. Done. And now we have area formula is pi r square. So area equal to pi into r into r. Done. Pi r square and display area, right? We're gonna display it. So print area. Done. Let me clear this one. Let me run this one. Save and run. It is asking me the radius. So 5, for example. There is an error. What is that error? Name R is not defined. Oh, okay. See, most of them will be doing this. Like I'm used to this formula, obviously pi r squared. So I forgot. Radius into radius. Whenever you get an error, you don't have to panic. You just have to, solve that. If you solve it, it means that you know something, okay? So try to solve the errors that you have. Don't try to escape from them. So I'm gonna clear again and I'm gonna rerun this. See, let's see. It is asking me, I'll give 5 again. It's working. Okay, 78.525 will be the area of the circle if that circle's radius is 5. Okay, so in this way we can, run each and every step from the algorithm, and we can see that practically by running them in program. Okay, here we also have one more interesting thing is calculate simple interest. I think this is the last exercise that we have. Okay, it's cool. Let's complete that within 5 minutes, okay? Be with me and do it. So first we're gonna take 3 inputs. So for you guys, I'm gonna do it step by step. So p equal to int of input. You can even give without int for my convenience so that it will be easy to calculate. I'm giving int. T is equal to int of input r equal to int of input. I can copy it, but yeah, I'm doing this. Now we're gonna create. Now we need simple interest. What is the formula for simple interest? P into T into R by 100. Okay, I have this formula and I'm implementing it. Simple, okay. SI equal to P into T into R equal to, no, sorry, R by 100. And that's it. I'm gonna display SI. Okay, so print SI. That's it. So let me clear this and let me run it. So save and run. So first, if P is, for example, 4 and T is, for example, 50 and R is, for example, 3, what will be the simple interest? 6.0. I'm sorry, I'm very bad at these simple interest calculations, guys, but if I do, like, you can give P value, T value, R value here, but I have formula and I just implemented it in the form of code. So yeah, you can just get simple interest from here. So guys, we are done with the exercises. I hope you learned and understood something new and interesting stuff related to algorithms and programming logic. If you still have any doubts, we are active in Instagram, Facebook, and you can also, comment on our YouTube channel as well. If you still have any doubts, where you can be in touch with us, we will help you out in learning them. Okay? Thank you for watching this. If you are up to this extent, that then it means the dedication that you are showing on the things that you want to learn. And I know that you're really curious. We're gonna upload really interesting stuff in the future. If you like the video, then hit that like button, and you can even subscribe to our channel for more interesting updates. Okay, thanks for watching.